Welcome back to Data Science with Sam, the podcast where we dive deep into the evolving world of data science and AI. I'm your host, Sam, and today we have an absolutely fascinating episode ahead of us. The episode name is Redefining Data Science in the Generative AI Era. We're exploring one of the most transforming periods in our field's history, especially in the data science. We're seeing that how generative AI is fundamentally reshaping what it means to be a data scientist. Joining me today is Claire Longo, a seasoned data scientist who has witnessed and navigated through this incredible transformation firsthand. Claire has over a decade of experience in data science and machine learning, having led AI teams at Arise AI, Twilio, and OpenDoor. She began her career as a statistician at DOE National Laboratories before transitioning into data science, where she built recommender system and scaled ML models into production. Claire has been at the forefront of MLOps and AI engineering best practices, publishing research and sharing insights on operationalizing models from traditional machine learning to modern generative AI applications. Currently at Comet, she focuses on advancing AI research and empowering the developer community through speaking, advising, and thought leadership. Welcome to the show, Claire. I'm really happy to have you here.
Yeah, thank you, Sam. Thanks for the great introduction. It's great to be here.
All right, let's dive into the Q&A section. Tell us about your journey from traditional data science to AI research. Especially, what was the pivotal moment that made you realize the field was fundamentally shifting due to the emergence of generative AI back in 2022?
Yeah, that's a great question because I'm sure there's a lot of folks out there that are also making that same shift and that same journey. For me, it was kind of an interesting journey. I started my career as a statistician. I'm a mathematician by training, so my degrees are in mathematics and statistics. And so I just kind of fell into just doing analytics for companies. And that turned into a data scientist during my career. I kind of like rode that first wave of data science. And then I became quite entrenched in the data science career path. I focused somewhat on the engineering side as well as like the model training side. Really learned everything there was to know about traditional like tabular machine learning models, deep learning models I was using quite a bit. Recommender systems became my specialty. And that all just seemed like the latest and greatest technology at the time. But then, as you know, recently, like Gen AI came onto the scene, and that really shifted my perspective on AI in general, as well as shifted the industry's focus, and my career shifted with it. So it was kind of interesting to like ride these different waves of like big data, data science, and then Gen AI. But what I've noticed is moving into like the Gen AI world from the traditional data science background, I'm still looking at things through a mathematical lens. There's kind of two core lenses, I think, for traditional machine learning. It's software engineering and mathematics. And those are still also the core lenses for Gen AI. It's really like those foundational concepts that we're going to need to guide the applications. Gen AI is maybe a little bit more powerful in a lot of applications than the tabular machine learning. So it is a really interesting area to focus on. But in the end, like it is a deep learning model. And so it is to some extent a subset of this broader kind of field that we've all been part of.
Yeah, definitely. I think that's definitely a powerful realization, not only for data scientists, because we know that, because if I go back to my academic programs like 10 years back, we remember that circles, right? Artificial intelligence, then machine learning, then deep learning. So we are still in that bubble. It's just like we are using a different term, generative AI, but the fundamental algorithm and the mathematics behind those generative AI hasn't changed. It's just uh, a more sophisticated linear regression or something that we are probably using. So thank you for that introduction and thank you for sharing your perspective. And I'm pretty sure the listeners already started engaging and they already start realizing what kind of discussion we are going to head into. So to that point, now what surprised you most about the LLM model's capabilities compared to traditional machine learning and like word-to-vec or TF-IDF? Because I'm pretty sure some of the listeners, they took the natural language processing classes and they probably still dealing with word-to-vec. So they might be interested to know about the differences between the sophisticated LLM models like GPT and those, like precursor models like word-to-vec or TF-IDF.
Yeah, that's a great question. There's a few things to think about there. The first thing that really stood out to me is like fundamentally different was the human-like responses that we get from the LLMs, and that's all due to them being a generative model with this non-deterministic nature of the output. With like, it feels like you're talking to a human, and that's not anything that I experienced with the older models in the NLP field. And the reason I think Gen AI is really just a rocket ship right now is because we have that human like interaction with the model. We can talk back and forth with it. And it inspires a lot of creative applications that maybe we didn't think of before. So really, that like almost like the user interface of it, the ability to like wrap it in a chat bot, or OpenAI has given us like an API that we can play with so we can integrate this into our software everywhere. That kind of smart way to like productize an LLM has really inspired us to really think about different use cases. And that has really, that's like the biggest thing that stood out to me is just how easy it is to interact with this model and how inspiring that could be in a creative context.
Yeah, I love that because especially the word non-deterministic, like that making that model to be kind of like more appeared as a human-like, right? So we can literally have a reasoning conversations with an LLM model, which probably won't be able to do with word to vec because they just used to follow our instructions. Whatever we tell them, they're just gonna go and do that stuff. But having that LLM, it's kind of like someone you're talking to. They're also providing you suggestions, not just following your instructions. So love that, the concept or the viewpoints you shared with our listeners. So just to move on to our next segment, it's more about the evolving role in this generative AI era, especially for data scientists like you. I mean, how has the role of a data scientist like evolved in 2, 3, 4 years? Because obviously data scientists are also using those AI models. So do you think there's a shift in their roles, like they're wearing a lot of hats more than they used to wear, like back in the day? So what do you think about that?
Yeah, so the role of a data scientist has always been evolving. And I think to be a good data scientist, we just have to evolve with the role because being in such a new, innovative field, I don't think the industry has really figured out the right roles and the right title. And that's why it's changing over time. And we just got to change with it. The
Mhm.
advice I give to everyone who is job searching, especially like early career, if you're not sure what role or title to look for, like maybe you're looking at AI engineer, MLOps researcher, data scientist, data analyst, it can be confusing to know which one to go after. And to make it more confusing, sometimes companies will not be exactly clear on what they're looking for. And so they might use the wrong title, but then the job description
Mhm.
actually has details. So the advice I give everyone is look at the job description. Does that look like something you want to do every day? Does it look like a great use of your skill set? And look at the title and the role second. So all that's to say, role is a little bit relative these days, but data science has been evolving. I saw it evolve from like early phase. I think the industry wasn't quite sure the difference between a data analyst and an ML engineer. And I saw those roles become more solidified in the industry and well defined. And now with Gen AI, I think we're kind of trying to figure that out again. Is a data scientist, an AI researcher, an AI engineer? And I'm seeing these kind of new roles and titles pop up. I see AI researcher and engineer quite a bit. And those are really just like people with a data science, math, engineering background who are focused specifically more on Gen AI. That's kind of the differentiation I get. So if you really want to focus your career on the Gen AI piece, and maybe you don't want to mess around with old traditional like linear regression or whatever, those might be the roles to focus on in this day and age.
No, that's a really insightful conversation. I would say that all the listeners over here who already have a traditional data science background don't get demoralized by with this, the influx of generative AI roles and stuff. You can still fit into that. Like, Claire mentioned, some of the roles like AI researcher will be a good fit for you because you already know the fundamental of algorithms and all kind of stuff. Thanks, Claire. I'm pretty sure my listeners will take it as a really valuable advice. Moving on to the next question, like you mentioned like, there are some other roles will be evolving and data scientists have to just adapt to that. And there is a new role, something like prompt engineering becoming a new feature engineering, right? Like data scientists are right now not writing the code to perform the feature engineering at the beginning of the data science pipeline. Rather, they're using prompt engineering to perform the same. So could you please elaborate that for some of the budding data scientists who are listening to this episode?
Oh, yeah, that's a great question. So, one of the things I love about generative AI is how flexible these models can be working with different data types. When I was working as a more traditional data scientist, I was doing a lot of feature engineering tabular data. And I think the saying holds true that I probably spent 80% of my time just cleaning data and processing it before I got to like the fun part of the model training or actually building like a product or a tool. So it was a little bit frustrating. And I remember when I built my first Gen AI application, it was a chat bot. And I realized that like I could just grab data from different sources, a PDF, JSON format, CSV, and just kind of dump it in a kind of messy way. And the language model was able to start to parse and make sense of it. So with a language model, you're given a lot more flexibility in terms of data input. The one caution I will say, it is a language model, and I do steer away from using language models for applications that should be a little bit more deterministic in nature. So if you have to
Yeah.
just like structured tabular data, like a traditional machine learning model might be the right approach. However, in the language model kind of paradigm with the Gen AI, there's architectures like RAG where you can be like pulling relevant text information out of a PDF. You could even like tag images and get that data in there. There's just a lot more flexibility in terms of interpreting this data in the language context that I've had a lot of fun with. And I just found that I spent a lot less time messing with my data and more time messing with the model, which I really love.
Yeah, I think that's probably fascinating, right? Because that's what a data scientist is supposed to be doing, right, as a part of their role. But
Right.
back in the days, a data scientist used to spend like 70 to 80% of their work in data processing, right? Making sure the data is clean and making sure the data quality stuff gets done even before they even start feature engineering or going into the predictive modeling. So half of the time they just churning the data and like getting the, trying to making sure the data is properly anonymized or even the feature engineerings are getting done properly. So I
Yeah.
mean, going back to your point, like you mentioned that, okay, now we can use AI to do that job that we really don't want to do. So you can spend more time on building models or even like making some tweaks in your machine learning algorithms to make it better. So now, if I want to dig deeper into the practical aspects, like we have seen this shift from feature engineering being king to prompt engineering and fine tuning in recent years. Now, has this transformation impacted your approach to problem solving as a data scientist, or do you still rely on some of the traditional data scientist approaches like performing feature engineers or EDA? I feel like you kind of touched upon that in your previous comment, but if you can elaborate a little more, that'll be great.
Yeah. So prompt engineering is actually a really important skill set, I think, not just for data scientists, but really anyone working with AI in any context.
Mhm.
Um, I have learned a really interesting insight about prompt engineering is that a mastery of the English language or whatever language you're writing the prompt in is actually key. One thing
Exactly.
that, yeah, it's really interesting. One thing that I noticed is that people who know the use case that they're building for, they can build better prompts. I'll give you an example. My brother works in the movie industry and he has a deep understanding of lighting and sets, and he knows
Mhm.
like the language used to describe images and scenes and that kind of stuff. So he used industry language and was able to come up with better Gen AI generated images than I could because I didn't know how to talk about that field. And I'm noticing this pattern
Correct.
over where people know like the lingo of their field and know how to talk about it. They're engineering better prompts. So there's something here about like really knowing your use case, mastering the English language or the language of your prompt. And that is really like, it's a very different kind of skill set that I wasn't as comfortable with as a data scientist. I'm like, just numbers, I'll figure it out. But now that kind of like communication ability, because we're communicating with the AI, is becoming key here
Exactly.
and prompt engineering. Yeah.
Yeah, I mean, interesting you said that because we had this Denver AI meetup last night, and we were having a conversation about who could be a better prompt writer. And somebody from the audience mentioned that the journalists are also becoming a great prompt writer. So it's kind of like getting to a point that where people with the technical aspect, like people who knows their stuff and also can write a great sentence in English. So that's going to transform into a great prompt. And I feel like at the end of the day, I guess you definitely need to have some programming language background, but you also have to be a great prompt engineer or write a better prompt. So maybe English is the world language and it's going to be more prevalent as we keep progressing further in the LLM world.
Mhm.
So yeah, so you mentioned that it just kind of like triggered that conversation we had last night, and somebody just mentioned that journalists are actually becoming a great prompt engineer. So who knows? They may probably gonna move into that field.
That's a really interesting insight. Yeah. It's something I didn't really expect to become like an important skill set as a data
Yeah.
scientist. We are. Yeah.
So yeah, all the data scientists out there, yeah, I guess you can also probably have to take a little bit of a class or making sure your text are contextual, tailored to what you need, so LLM can give you better direction or provide you a better guidance on running your data science pipeline. Now, so that is kind of like a feature engineering part and stuff. And now we kind of like touched upon that, most of the time data scientists spend in just cleaning the data and all kind of data processing and cleaning stuff, right? So do you think that that process has been changed drastically due to the emergence of generative AI? Like, do you think data scientists are actually spending less time in cleaning data or even pre-processing it before fitting into a predictive modeling?
Yeah. It depends on what kind of project you're working on. Because the advice I always give is we should choose the model for the project, not the project for the model. And so
Mhm.
if you have a lot of tabular data and you're trying to do something that there's already a very reliable model to do, that is good at this, then I would explore that first. I typically use LLMs for language tasks. I love them for
Mhm.
chatbots, they generate emails, things like that, anything that's really language based. So the first thing I want to do is like just choose the right model here. And if I do have to go down the path of a Gen AI model and you have a lot of unstructured data, the data
Mhm.
cleaning is a little bit I've
Correct.
easier than traditional machine learning. I built a lot of RAG systems, and you just
Mhm.
need to like create a vector database and put all your data in there. And I don't know, you could clean it, you could not. I typically don't. I think the LMs are pretty good at like parsing through
Mhm.
like JSON thing. The key data structure actually that emerged as being so important, and I used it a little bit as a data scientist. I had no idea that this data structure would be like the foundational data schema for AI today, but it's embeddings. It's just those vector
Exactly.
database.
Yeah.
I remember like as an early career data scientist, I was trying to explain embeddings a lot to like the engineers in
Mhm.
my team to help me deploy models. I had no idea that this would just be like the core data structure for Gen AI, but it is today. And so I think really understanding embeddings and how to get value from them and how to work with them is going to be a key skill here.
Yeah. I'm pretty sure you probably had a whiteboard session with your early career data scientists telling them, okay, this particular words or text, transforming into this vector, right?
Yeah,
I
you've
could
probably
probably
seen the
yeah.
visualization.
Yes,
Yeah.
I remember some of those very like 7, 8 years back, I took this data science course offered by Andrew Ng, and that time Andrew Ng just started Coursera. And remember, his one of his first lessons was how to break down these words and transform it into vectors. Those are like fascinating. Back in the days, that was probably the building block of understanding embedding in the natural language processing work. So yeah, thank you for your response. I'm pretty sure our listeners are enjoying this conversation. So moving on to the next one, like you mentioned that like the data scientists still need to rely on traditional models in data science work because it's kind of a case by case scenario. What kind of the issues you're trying to tackle, right? So now let's say that we are using a generative AI models to do the prediction, for any business use case, doesn't matter, but in that case, how do you approach the explainability and interpretability challenge with generative AI models? Because, like you said, it's a non-deterministic. It's kind of a black box to us. So, how do you even decipher the outcome of the model and also explain that to your internal stakeholders or your business customer?
Yeah, ooh, that's a tough one. The question of explainability, I guess, has never gone away because that was an
Yeah,
issue then,
yeah.
it's an issue now. Um, Yeah, so explainability, the way I think about Gen AI and these non-deterministic models is I don't want to try to force them to be deterministic because then we're losing the power and the value of them. So
Correct.
if we need a deterministic approach, I will code some if then loop and we'll use that and not use Gen AI. I try to really leverage the non-deterministic nature of these models as a feature, not a bug. I know people talk a lot about hallucinations and how it's a problem. In some contexts, you need to monitor for that kind of stuff. But I think it's also important to understand the hallucination is just an aspect of these models having probabilistic output. And it's also why they're so powerful. So I don't really go towards like explainability. I go towards what I like to think more of like
Hmm.
auditability, if that's a word. I like having the ability to audit the system. So what
Hmm.
I really like is when I'm putting together like an AI application, it's typically not just one single call to an LLM. It's probably a lot of business routing logic, maybe some data cleaning, maybe I've got a vector database. So you typically have like kind of a lot of steps in this pipeline. And I like to be able to look under the hood of that application and know what the inputs and
Mhm.
outputs are every step of the way. And that gives me the ability to like audit the system. So if I get like a weird output, I can trace exactly what data generated it, what user input. And that helps me kind of debug and keep these things on the rails in terms of monitoring, but it doesn't give you that full explainability. Now, the other thing with explainability, though, is that LLMs, being language models, are pretty good at explaining themselves. So you can also just ask it to, like, hey, tell me why you gave me this output. And it can be helpful in some contexts for like debugging an issue. I would use that approach with caution because it's going to tell you what sounds good. It's generating language. It's going to tell you something that sounds pretty reasonable, but it can be a good kind of like directional indicator of how the model might be reasoning, I guess, under the hood.
Yeah, I think that seems like a fascinating and very reasonable expectation, and believe all the data scientists listening to this episode should keep that in mind in terms of like maybe auditability is the better way to address that because there are certain things we should not be able to explain, or we should not like put a guardrail on LLM model that's going to hinder its ability to becoming more non-deterministic. So I think we should let LLM do its stuff, but we need to make sure that how we're going to put guardrails to audit that outcome that is fitting, for our data science work. So I like that. Thank you for sharing your perspective on this. Like where human experts would be initially kind of like thinking about how they can predict that outcome coming out of an LLM models. Now, this brings up an interesting philosophical question. Like, I mean, what do you think that what role does this? I mean, the traditional statistical thinking is always necessary for a data scientist, right? So now, in this era of generative AI and everything is so fast pacing, we have easy access to data. We even have easy access to model like LLM that can probably do your prediction work. So, keeping all of this into consideration, what role does traditional statistical thinking still play in this era? Especially a data scientist, would they still need to have that acumen to have a statistically think about building a model, or is it something not so like primary requirement anymore?
Yeah, yeah. So I think I'm biased, but I think statistical thinking is a primary requirement for all of life because I think everything we do in life has some
Mhm.
uncertainty, some outcome that we can try to predict. And AI is no different. But specifically, like the statistical thinking is going to help you in the
Mhm.
Gen AI field in a couple ways. One is just general experiment management. There's proper like
Yep.
scientific experiments and hypothesis testing that I think will really help us build reliable systems at scale and production. When I first started tinkering with Gen AI, I was like running a few outputs, running a few things through the LM, looking at the output and tweaking my prompt. And I was essentially just like overfitting to whatever I wanted to see, just through a few examples. And that's just not good scientific experimentation. You've got to
Yep.
build like a basic data set. You've got to have metrics to measure things. You need to do that kind of unbiased hypothesis testing. So that's something that's just going to generally help us in that kind of R&D phase of building things. The other way, like non-determinist or statistical thinking helps us is really interpreting the non-deterministic nature of LLMs. Just knowing what a hallucination is, why you got it, what parameters you can tune to reduce it. It can even guide like where you want to apply LLMs versus not. Just understanding how that output is generated in kind of a statistical nature.
Yeah, no, totally agree with that, especially the second part. Like, if you want to really measure hallucination and how much it's kind of like differing from the actual benchmark, we definitely have to have some sort of a model validation. I mean, I don't know what kind of validation we should do in that case. Maybe a cross validation because we can probably do a lot of validation on that LLM models to see where it's showing that kind of hallucination. But I do agree with you on the fact that obviously, especially given the fact that LLM model is non-deterministic, it can showcase or exhibit some hallucination. We definitely need some sort of a guardrail at this model validation standpoint where the statistical thinking would be very necessary. So yeah, moving on to looking ahead 2, 3 years, what skills should aspiring data scientists listening to these episodes focus on to remain relevant in this AI renaissance?
Oh, yeah. Okay. It's tricky because the industry is literally changing probably as we speak. There's new papers and new model architectures like all the time. And it can
Yeah,
feel, yeah, it feels kind of daunting to keep up with it. It can feel overwhelming. So
I
the
always
first,
feel like drinking from the fire hose every morning when I go through LinkedIn and see all these stuffs coming out of everywhere.
yeah. And just as I feel like I'm like on top of the latest trend, there'll be like a new trend. I'm like, oh, I got to go learn this
Yeah,
other thing. So it's overwhelming, but I think the first step is just realizing that everyone in the industry is feeling that way, even very senior people, because there's a lot of new things that are coming out. So I think the most useful skills we can build
Mhm.
is one, just resilience as practitioners and confidence, just the ability to go in and tinker with things, learn new things, try things, have that kind of learning and growth mindset and not giving up when we feel overwhelmed. I think that's a number one thing. It's really just a personality trait. In terms of the actual technical skill sets, I think like engineering best practices, knowing how to design software, knowing how to properly test it. I don't think we need to really be that good at writing line by line code because AI is actually generating code for us really well, but we need to guide that AI to do it properly because I've seen it
Exactly.
output really bad code. So we need to know
Yeah.
what is good, what is bad code. So going up to kind of the higher level principles of software engineering will help us implement the AI. And then I think core mathematics. And when you major in mathematics, you learn like a lot of different concepts in math, and not all of them are relevant here. So when I tell people like,
Yeah.
oh, you got to know mathematics, you don't need all of it. What we need is like probability, statistics, linear algebra, uh, and that's probably it, honestly, unless
That's
you can
probably
think.
it. Yeah. Yeah, I mean,
Those are
I
kind of
guess that's kind of like, the whole neural network and machine learning models evolve around.
yeah. Yeah, so just master those and then everything will start to be pretty intuitive. When new papers come out with new model architecture, you can read about it, you can implement it easily. And the reason I go to kind of those core principles is like there's going to be new stuff all the time. So we just need the tools to understand the new stuff.
Exactly. I mean, that's such a valuable advice because all the data scientists listening to this episode, I mean, the overall concept, the mathematics, the science behind everything is not going away. It's the same thing. We
Right.
are just, improving as we training the model further and further, coming up with billions and billions of parameters, right? The core concepts still remain the same. And I was reading this NVIDIA research paper where they're kind of like, coming up with the idea of that maybe in some cases small language model might work better than large language models. So we don't know. We are still researching and stuff, but they are not changing the fundamental concept that powering the LLM model, right? So it totally
Yeah.
just goes with what you said. We still need to learn mathematics. We still need to understand the concept of linear algebra and how the regression process work in order to understand how the neural network model or hidden layers, all those kind of good stuff, right? So yeah, thank you for your great advice. I'm pretty sure our data scientists are making notes of this while we are going through this episode. Before we wrap up, I want to ask you another bonus question, and that's kind of my favorite question. And again, it could be it sounds like a curveball. I'm just using a baseball analogy. So if you had to predict one major breakthrough or shift in AI and data science that excites you most, what it be and why?
Oh, I love this question. Honestly, there's so much exciting stuff, but this is actually a really easy answer for me. I think it's world models. The reason I think about world models is this thing called like large world models right now. I'm like got like three different tabs open with research papers. Like this is where I'm deep diving right now, just to understand it and think about how we can advance there. But essentially, like what I think we need right now is like we have LLMs. They're really good language models, and they can interface with language inputs and outputs. What I really want the ability to do is represent a physical world so that we can mathematically define how robotics might interact with the AI or other kinds of data, not just language and video and audio. So I'm really thinking about how do we mathematically represent the physical world and encode that in a model so that we can kind of control what we're optimizing for, steer the models, and interact across different mediums. So if I had like a lot of extra time, which unfortunately I don't, I would dive into models. It's a really interesting concept.
Just like a follow-up thing, do you think the quantum computing might help us to get into that direction of world model because it will have more computing power? I mean, it can be probably help us to make the model more deterministic than what it's not right now. But just wanted to throw it out since you mentioned that.
I'm not sure. I'm not sure where we're headed with quantum computing. It's not really my area of expertise. It's more of like an area where I'm really kind of fascinated. So I'm following along there, but I really don't have any insights on where that might go or how that will help us. So I'm keeping an eye on that.
Yeah, I think this is fascinating, Claire. I mean, the thing you mentioned, I think the world models, I think that's probably the direction we should be heading at some point
Mm.
of time, having all these LLMs coming from different, where all they're going to combine together. And maybe we're going to have a powerful world model that's probably going to solve a lot of quizzes. Maybe it's going to help us with the climate change and some of the existential threats that the Mother Earth might face in future. So thank you, friend. That's a very fascinating, and I'm looking forward to the future. So excited for how LLM on the AI will take us to the next journey and making the world better than we found it in the first place. So before
Absolutely.
we wrap up, Claire, this has been an absolutely fascinating episode, and I love that thought-provoking conversation and all your viewpoints and perspective. I'm pretty sure my listeners also kind of enjoyed this. Now, for the listeners who wants to stay connected with your work and insights, where can they find you?
Yeah, so I'm most active on LinkedIn. So just give me a follow on LinkedIn. I also have a YouTube channel, and I'm really just mostly posting on LinkedIn. And I respond to DMs, I respond to messages. So if you want to talk to me about world models, mathematics, Gen AI, vibe coding is a popular topic right now that I've been really leaning in on. Yeah, I'd love to engage in conversation. So just send me a message.
Thanks, Claire. It was such a wonderful experience to have you with us today. And for my listeners, if you enjoyed this episode, please subscribe to Data Science with Sam, whether you get your podcast or leave us a review. It really helps other data scientists to discover this show. This has been a great episode with Claire, and I'm your host, Sam, and we'll see you next time.
Bye,
Thank you.
everyone. Thank you, Sam.